Welcome to the A2A Cessna 172 taxi and before takeoff stuff. We'll be doing taxi and run-up. Now, I've relocated the aircraft here to Craig Municipal Airport. This is the airport we're going to be doing when we're talking about normal takeoffs and landings and stuff. We're also going to be doing our taxi here. Now, this is a controlled airport, but I've disabled AI traffic, and I'm not going to be using default ATC for this, mainly because where I say you need to call ATC, you could use default online VATSIM IVEO or whatever ATC program you're using. So, and the real world weather has also been disabled because the weather right now at this airport is not favorable for what we're going to be doing. It's raining with a low overcast right now, so I've set it up for just a typical summer day. Probably about early morning. The clouds are a bit high. They're about 4,000 feet, and they're scattered. Nothing major. Light wind. We're going to be talking today about taxiing. Now, you might think, oh, taxis are easy. Just give it some gas to get to the runway. Well, there's a bit more to it than that. Specifically, when we're taxiing, today we're going to be talking about soft surfaces versus hard surfaces, obstacles, and stuff like that. Now, I also want to discuss movement areas versus non-movement areas, sorry, not movement areas, control areas versus non-controlled areas. We're here on the ramp at, this is the Sky Harbor ramp at Craig Municipal Airport. This is where the Sky Harbor FBO is. I learned to fly here, by the way. This is the airport where I got my pilot's license at. I started at a flight school that was at this ramp here called North Florida, and they eventually closed down. I went to a flight school here called Sterling, which is at this ramp over here. Alright, so we're here at Craig Municipal. We're at the Sky Harbor ramp, which is a non-controlled area. We could taxi around in circles all day over here and never have to talk to ATC. Because you'll see aircraft moving around over here all the time, pushed and pulled by either the FBO's tug or their owner, just moving around. Now, that non-control area ends at this taxiways right here, these two taxiways. That is because here you're getting into the open taxiways, which are under air traffic control jurisdiction. A lot of times, good sceneries will have a marking on the taxiway somewhere. It's similar to the runway hold short marking, but if you look at the runway hold short marking down here, you can see that the hold short marking in a runway is a double solid line and a double dash line. However, the markings for a control versus non-controlled area are like that, but instead of double, it's single. So a single solid line and a single dash line. The solid line means you cannot pass that solid line without clearance from air traffic control. So the solid line would normally be on the side of the non-controlled area. The dash line means you can pass by it without air traffic control clearance. So if you're on the side with the dash line, feel free to taxi right over it without talking to anybody. If you're on the side with the solid line, you have to call ATC first. Alright? So, we're here in a non-controlled area. I'm going to go ahead and get the aircraft situated in front of the taxiway. You can do this in real life, too. And even in flight sim, you can get the aircraft situated to a movement, or close to a movement area where that whole short line I just talked about would be. Now, when you first get going, you want to give the aircraft a little bit of gas and then move the throttle to idle and then test your brakes like I just did there. So like get it going, test the brakes are good. Alright, I'm going to stop the aircraft right here. Alright, another thing we want to talk about while taxiing is wind direction. You can see the windsock just out of the corner of the airplane over there. I'm going to tune the ATIS real quick to get the wind info.
Craig, airport information Alpha 1914 Zulu with 071 at 8. Visibility greater than 20 miles. Sky condition 4000. Scattered. Temperature pre-warp 2.1.
Alright, 071 at 8. Now, notice I set my heading bug, and remember from the startup checklist, that is also on the startup checklist. Set the heading bug, and what it means by that is set the heading bug to the current wind. Actually, was that on the startup checklist? I don't know. I got a checklist here. Let's run through the pre-taxi checklist, which I made a mistake. We should have done the pre-taxi checklist while we were still in the parking spot. Oh well, we'll do it here though. So ATIS ASOS obtained, GPS database is checked, GPS signal is checked, autopilot test, verify the autopilot self-test complete. When you first turn the avionics on, autopilot runs through a self-test. Manual electric trim. Now, in real life, the manual electric trim is these two switches right here. That is the manual electric trim. Pushing them up will trim nose down. Pushing them down trims nose up. So, I have a switch on my joystick that works similar to that. So you watch the trim wheel when I push it. Now, just like in real life, manual electric trim moves the trim wheel slowly. So, it's a good idea to set this with the mouse, where you can move it a little quicker, and then use the electric trim for finer settings if your joystick supports that feature. If not, use the mouse wheel. Just hover your mouse over the trim wheel and use the mouse wheel to make those fine adjustments. Alrighty. That's all we can do with the autopilot self-test. Elevator trim set for takeoff. Flight controls free and correct. We typically also do this one as the run-up checks. Just move your flight controls and make sure they move their full deflection. Nothing's blocking them, and the correct ones move with the correct control inputs. Alrighty. Altimeter is set. Heading bug set. Heading indicator set. Autopilot pre-selected altitude set. Fuel quantity checked. Navcom radio set. Transponder squawk standby. On the transponder, it's been a recent change. Used to, they would tell you to squawk standby, which would be that position right there. Nowadays, though, at least in the U.S., they want you to squawk on whenever you're on the ground, and before you take off, and after you land, set it to altitude. Or after you land, set it to on. So when you're taking off, you'll set this to altitude. It'll be on altitude whenever you're airborne. And when you are taxiing on the ground and after landing, you set it to on. You should no longer have to set it to standby unless for very specific reasons. So I'm going to set it to on right now. GPS flight plan is not required. HSI we do not have. OBS is nav source. COM 1, COM 2 checked. Parking brake release brakes checked. Now, taxiing the airplane. Pretty simple. You give it a little bit of gas to get going, and then you back off on that gas a little bit to keep it going. It takes a decent amount of gas to get going, especially on a soft surface like grass. It takes a little bit less gas to get going on a hard surface like asphalt here. Now, you need to keep your heads up when taxiing the aircraft for obstacles. See these taxiway signs if you're flying an airplane with a really, really low wing could also be obstacle, hazardous to you. Anything like that. Some airports will have high taxiway lights or stuff. Make sure you don't hit anything. Typically, around taxiways, the area is pretty clear. Another thing you also need to be looking out for is traffic. We have some traffic out there. So, in particular, this traffic here is special. He's a jet and we're a small prop. Now, you always want to give traffic a decent berth, but especially so with jets. We're going to be taxiing behind this guy, so his jet wash can be pretty dangerous to us, his jet blast. Now, he's going to the same runway we are over there. So, we're going to let this guy go by first. Now, you may not have to. You could cut in front of this dude if you wanted to, if he's pretty far down and ATC wants you to get moving. This guy's close enough now, we're going to hold for him. If you can get in front of a jet, we're going to go run up anyway, so he's probably going to take off before us, in which case we'll have to talk about wake turbulence. So we'll hold right here. Now his wings are wider than the taxiway, so you want to give him a wide berth on all directions. Alrighty. We want to keep at least 100 feet behind this dude. Just like you're driving behind a putwood truck on the highway, you want to stay at least 100 feet back from them. This way the jet blast is not a problem for you. So I'm giving her a little bit of gas. Okay. As we taxi, there's another turn coming up. You want to check a few things. One, make sure your attitude indicator is free and correct. It's up and it's not really moving too much. That's good. Secondly, you want to make sure your turn coordinator banks in the direction of the turn on the taxiway to make sure it's working correctly. Also, on 90-degree turns, the slip and ball should deflect a decent amount. And secondly, make sure the heading indicator turns in the correct direction and indicates a decent heading within plus or minus a couple of degrees of your magnetic compass. We'll do a more official magnetic compass check once we're on the runway. Now, here on this nice wide, straight taxiway, I'm giving it a little bit of gas and get us going faster. Okay, here we have a bit of a bank, so watch those gauges I talked about. Alrighty. Now, when it comes to taking turns, the 172 with rudder input alone does not turn very well. You often have to use brakes, in which case you got differential braking on this airplane. So I'm going to taxi straight ahead into the run-up area. See, I'm using just rudder right now. Now I'm using the brakes. Turns a lot tighter. Oop, I just put one of my wheels in the dirt. Oh well. Alright, we'll position our airplane for the run-up check. And we get a good view to watch this Learjet take off. Alright, set the parking brake once we're in the run-up area. Now, one other obstacle you need to be wary of is helicopters. These things can be vicious around fixed-wing aircraft. So, what you want to be aware is you need to treat them as if they are the wind direction. Those rotors put out a lot of air and can throw your aircraft for a loop. Really, they can. So, if you see a helicopter taxiing around, taking off, or landing near the taxiway, like say you're taxiing along right here, then treat that as a crosswind. Wherever that chopper is, treat it as the wind direction that the wind is coming from. And use full deflection at all times, because these things can throw you. You should be very wary of them. They are dangerous. They're fun. Fun as heck to fly, like this madman. But, yeah, they can be dangerous. So treat them like a crosswind, and everything will be peachy. Let's watch him, see how he does his takeoffs. This professional Learjet pilot. Up, up, and away. He's disappeared. It's too far out. Just see his landing lights now. It's like a UFO flying around over there. That's neat. Alrighty. Okay. This is the before takeoff portion. So we're in the run-up area. We want to talk about before takeoff. Now, we've covered all the stuff we need to for taxi. So let's go through before takeoff checklist. This is also known as run-up checks. We're basically just testing everything. One last check in the aircraft to make sure everything's working correctly, and we don't want to take any problems in the air with us, do we? Alright, so we're going to be checking things like engine, final setup of avionics, and stuff like that. Alright, so before takeoff checklist. Seats and seat backs locked, seat belts fastened, cabin windows closed and locked. I'm going to leave my window open. I do this often in real life because it's freaking hot, and this airplane's air conditioning is not very good when you're sitting on the ground not moving. That's because it's a ram air conditioner, and the faster you're going, the more air blows into the cabin. Since that doesn't work too well when you're sitting still, we like to leave the windows open until we're cleared for takeoff. Alright, fuel selector on both. Elevator trim is set. Set the moving white line here with this onto that little triangle. Mixture, best power at this airport, that would be full rich. Throttle, 1800 RPM. Now we use the parking brake here. It's a good idea to also hold the brakes if you're using rudder pedals or flying this airplane in real life. Hold the brakes while you do this. That way if the parking brake fails, the airplane won't run off on you. So we'll advance the throttle to 1800 RPM, just shy of that green arc there. Alright, there's 1800. Magneto checks. Right mag. Left mag. What you're looking for there is an RPM drop. You want to see at least a 100. You don't want to see more than 150 RPMs drop, but you also don't want to see more than 50 in between the two. They drop both the same. Okay, suction gauge. Vacuum is in the green. Engine instruments and meter, oil temp and pressure, fuel flow, everything's good. Alright, enunciations. No enunciations at the moment. Idle speed, check. What we do here is pull the throttle all the way back. The RPM should drop to roughly around 600 or 700. There they are. The engine runs a little bit rough at these low RPM settings. Just advance it back to around about 1,000. What you're testing there is the stop block. The throttle assembly has a stop block in it that prevents you from pulling the throttle out too far. That way you don't kill the engine just from pulling the throttle back at idle. And that's to make, you're testing it there to make sure pulling the throttle all the way back won't kill the engine. Alrighty. Flaps set. Now we're doing a normal takeoff from this airport, so we can leave the flaps up. Transponder set and set to altitude. Alrighty. Autopilot off. Pitot heat as required. Pitot heat you only need during icing conditions, which are temperatures within 10 degrees of freezing, which is 0 degrees Celsius, 32 degrees Fahrenheit. So 10 degrees Celsius or 42 degrees Fahrenheit or lower, then you need to then you're going to be getting into icing conditions, provided this one other condition is met. Visible moisture. Fog, clouds, or high humidity, that's all considered visible moisture, and you'd want to have the pitot heat on when both of those conditions are met. If it's one or the other of neither, then you're fine, but pitot heat on, I personally like to turn the pitot heat on whenever it gets cold, like in that 10 degree range, so definitely check. And in case you're wondering, you got the outside air temperature right here. Just click that button at the top because it normally displays the volts, but I like it on Celsius. It's a pretty hot day today, summer. Alrighty. Landing and strobe lights, just flip them on, and now we have all the lights we need for VFR day operations. Takeoff brief. Alrighty. Up here at the top of the checklist, they have a departure briefing, so let's go through it. The winds were 170 at 8. Flaps will be up since this is a normal departure. Weather is favorable for VFR flight. Terrain is not an issue. Minimum safe altitude is going to be 700 feet. That'll put us above all obstacles within the airport. That's also the safety altitude for when you're taking off. Again, safety altitude is when you're making traffic pattern, you will normally climb straight out from the runway to 500 feet above field elevation before you start your turn to crosswind. 700 feet above field elevation is what I like to term the safety altitude. Assuming you made that turn at about 500 feet or sooner, then when you hit 700 feet above field elevation, also safety altitude, then you are close enough and high enough to the airport that if your engine failed after this point, you could most likely make it back to the airfield maintaining best glide. Now, obviously, if you fly out after 500 feet, you know, that's provided you make the turn at 500 feet or sooner. A lot of times ATC might ask you to start your turn sooner than normal for spacing, but that's safety altitude. performance, we can expect full performance today. Density altitude is going to be a little bit high because it is temperature, so we might take up more runway than we normally would. I've flown the aircraft in real life before on a really, really hot day, like approaching triple digits, and the airplane just would not. It didn't want to fly and it didn't want to land. Yeah, it was so hot. We took up most of the runway, which is a 4,000-foot runway, just trying to take off. And when we landed, since it was an asphalt runway, there's rising hot air over those on hot days. It really, really hurt the landing performance. Alright, takeoff brief. Departure procedure. We're VFR, so we'll just follow standard traffic pattern departure procedures. GPS is not required. Autopilot is off. Takeoff alternate. This runway is long enough. We should be able to stop on the runway if necessary. And for emergencies, below the safety altitude, we'll land straight ahead. In Flight Sim, you have a bit of an advantage. You can actually plan this ahead. If you go to top-down view and see, you can see where you might have to land should the engine fail on takeoff. We can see we have, if we're taking off from this runway, we have some roads we can work with. I think that's a power line over there we might be able to use. I'd like to avoid a power line as only land there as a last-ditch effort. In fact, I'd say landing in the trees would probably be better than a power line. But we do have some highways to work with. We also have the St. Johns River just north of the field. Alrighty then. So that's the departure briefing complete. Departure time, note, and one on the runway, cross-check the compass. Alright, we're doing a normal takeoff today, so flaps are up. And we'll rotate at 55 knots and climb out at VY, which is 79 knots in this aircraft. I think 74, actually. The checklist says 79, but I'm pretty sure it's 74. At least in the 172S it was. We'll go with 79 so that's what the checklist says. Alright, takeoff checklist. We want to do this one first, too. Flaps are up. Throttle will be full. Mixture, best power, elevator set. Climb to 70. Climb out at VY. Flaps retract to safe altitude. Alright, so let's go over what's going to happen. When we get on the runway, we're going to cross-check the heading we're on with the magnetic compass to make sure we're on the right runway. And we're going to advance the throttle to full. Since this is a normal takeoff, we don't have to worry about taking up too much runway. And it's a nice long 4,000-foot runway for us to work with. Okay, we'll rotate at 55 knots, and we'll climb out on runway heading to 500 feet above field elevation, which is pretty much 500 feet on the MSL here, on the altimeter. And we'll climb out at VY, which is, again, 79 knots. At 500 feet, I'll make we'll say a right turn to fly south, and we'll continue climbing at VY to 700 feet. At 700 feet, we'll call safety altitude, and then continue climbing to 1,000 feet. 1,000 feet above field elevation. You want to stay at VY the entire time. Once you get above 1,000 feet above field elevation, you could pitch down a bit and speed the aircraft up to a nice climb speed. Climb speed is 85 to 70 knots indicated. So you can stay VY. I like to use 80 knots. 80 knots are just slightly above for my climbs above 1,000 feet because it gets you going to your destination faster and gives you a good climb rate. Alright, so normal takeoff. Alright, that is the taxi video. Hope you enjoyed it. The next video we'll be covering takeoffs. Grab the mag with the mouse. Wait for it to start. There it is. Fuel mixture full rich. Notice the engine started up before I moved the mixture into the full rich. We have oil pressure rising. Oil pressure's in the green arc. Okay.